It's the technology behind Bitcoin, Ethereum, and countless cryptocurrencies. It's been called the future of money, the backbone of Web3, and even a revolution in digital trust. But what is blockchain, really? Let's cut through the hype and unravel how this technology actually works, why it matters, and where it might be taking us next. Welcome to Unravel, Technology and Innovation, where we simplify the tech shaping our world, one concept at a time. Today, we're diving into the world of blockchain, the digital ledger that makes cryptocurrencies possible and that could one day power much more than money. At its core, a blockchain is just a database, but one that's designed in a completely different way. Instead of being stored in a single server or controlled by one company, a blockchain is distributed across thousands of computers. Every participant, called a node, holds a copy of the entire database. This database isn't just a list of numbers. It's a ledger of transactions, a digital record of who sent what to whom and when. Each set of transactions is bundled into a block. When a new block is created, it's linked to the previous one, forming a chronological chain of blocks. Hence the name, blockchain. Here's the beauty of the design. Once data is added to a blockchain, it's extremely difficult to change. Each block contains the data itself, for example, transactions, a timestamp, a cryptographic fingerprint called a hash. Every new block includes the hash of the one before it, creating a secure chain of references. If someone tried to alter even a single number in an older block, its hash would change immediately, breaking the entire chain. This makes blockchain tamper-resistant. Instead of trusting a central authority, users trust the network itself, secured by math and consensus. So, how does everyone agree on what the real version of the blockchain is? That's where consensus mechanisms come in. In traditional systems, a central authority, like a bank, verifies every transaction. In blockchain, the network verifies it collectively. The most famous method is proof of work, used by Bitcoin. In this system, computers compete to solve complex puzzles. The winner adds the next block to the chain and gets rewarded with cryptocurrency. It's secure, but energy-intensive. That's why newer systems like proof of stake have emerged. Instead of racing to solve puzzles, validators are chosen based on how much of the network's currency they stake as collateral. It's far more efficient, and it's the system now used by Ethereum. Regardless of the method, the goal is the same: make it nearly impossible to cheat the system. Blockchain removes the need for a central middleman. That means transactions can happen directly between people, anywhere in the world, without banks or payment processors. Every transaction is transparent, permanent, and traceable. Yet, because users are identified by cryptographic addresses, not names, it still preserves a level of privacy. This combination, transparency, security, and decentralization, is what makes blockchain revolutionary. While blockchain's first major application was Bitcoin, the technology has grown far beyond digital cash. Here are a few examples of how it's being used today. Smart contracts. These are self-executing digital agreements coded directly onto a blockchain. Once conditions are met, the contract automatically triggers, no lawyers or middlemen needed. Ethereum pioneered this concept, opening the door to decentralized apps, or dApps. Supply chain tracking. Companies can log every step of a product's journey, from raw material to store shelf, on a blockchain. This helps verify authenticity, prevent fraud, and ensure ethical sourcing. Voting systems. Some governments and organizations are experimenting with blockchain to create verifiable, tamper-proof digital voting. Digital identity. Instead of dozens of passwords and logins, blockchain could give individuals a secure, unified way to prove who they are online. NFTs and digital ownership. Non-fungible tokens use blockchain to certify digital art, collectibles, and assets, giving creators new ways to sell and protect their work. Like any powerful technology, blockchain comes with drawbacks. Scalability. Most blockchains can only process a limited number of transactions per second, far fewer than systems like Visa. Energy use. Proof-of-work networks consume huge amounts of electricity. Complexity. For many people, the technical side of blockchain remains confusing and intimidating. Regulation. Governments around the world are still figuring out how to handle blockchain-based assets. Irreversibility. Once a transaction is added to the chain, it can't be undone, even if it's a mistake or a scam. These limitations don't make blockchain useless, but they show it's not magic. It's a tool, and like all tools, it needs refinement. The blockchain space is evolving fast. Layer 2 solutions like the Lightning Network and Polygon are improving scalability by processing smaller transactions off-chain before recording final results on the main network. Proof-of-stake systems drastically reduce energy usage, making blockchain more sustainable. Interoperability projects aim to connect different blockchains together so assets can move seamlessly between them. And enterprise blockchains are being adopted by banks, healthcare companies, and governments for private, permissioned networks. The goal is the same: to make blockchain faster, cleaner, and more useful, not just for crypto traders, but for everyone. At its heart, blockchain is about trust, but without needing to trust any one person or institution. It's a shared digital record, maintained by everyone and controlled by no one. It proves that transparency and privacy don't have to be opposites, and that secure cooperation can exist across the entire internet. It's not the future of everything, but it may be the foundation of a more transparent and decentralized digital world. So, what is blockchain? It's a decentralized, tamper-resistant ledger that records transactions securely and transparently. It's the technology that powers cryptocurrencies, smart contracts, and a growing range of digital innovations. Blockchain turns trust into code, and that simple idea might reshape how we exchange information, value, and identity in the years to come. Got a question or topic you'd like unraveled next? Leave a comment below, and don't forget to subscribe. As we continue to explore the world of technology and innovation, one concept at a time.